Our objective in this lesson is to solve quadratic equations by factoring. Let's have a quick activity. Trace by origins. First one, we have 2x squared plus 10x. What we can do here is to determine the greatest common factor. So for 2 and 10, the greatest common factor is 2. Let us factor it out. For x squared and x, the greatest common factor is x, the one with the lower exponent. So let us factor out x. When we factor out 2x from 2x squared, what was left? That is the same as asking yourself, when 2x squared is divided by 2x, what do you have? So 2 divided by 2 is cancelled out. X squared divided by x, you still have 1x. Now, 10x divided by 2x. 10 divided by 2 is 5. And then x will be cancelled out with x. Let us do quick checking. 2x times x is 2x squared. 2x times 5 is 10x. So our answer here is correct. Next one, we have x squared minus 9. 9 can also be expressed as 3 squared. If that is the case, we have difference of 2 squares. The factors of difference of 2 squares is simply extracting the roots of the terms. So for x squared, the square root of it is x. We're going to need 2 of that for the 2 factors. For 9, the square root of 9 is 3. So 2 3's as well for the 2 factors. For the sign, we have 1 negative and 1 positive. Here are the factors of x squared minus 9. The third one, we have here a trinomial. So we are going to think factors of 6 that when you add will give you negative 1 as an answer. The square root of x squared is x. We're going to need 2 of that again for the 2 factors. The factors of 6 that might give us 1 as an answer are 3 and 2. Now for the signs. Since our middle term is negative, then the bigger number here should be negative. So we have x minus 3, and this one should be positive. Quick checking, negative 3 times positive 2 will give you negative 6. Negative 3 plus 2 will give you negative 1 as an answer, and that is our middle term. So our factors are correct. Previously, you have learned how to solve quadratic equation when we do not have a linear term, meaning b is equal to 0. But what if we have a complete quadratic equation or just the constant term is missing? How are we going to solve it? Today, I am going to teach you how to solve quadratic equation by factoring. We are going to need the knowledge about zero product property. It states that for every real number a and b, if a times b is equal to 0, then a is equal to 0 or b is equal to 0 or both a and b are equal to 0. Here are the steps in solving quadratic equation by factoring. 1. You have to write the equation in standard form. I bet you already know that. Number 2, factor the equation completely. So you really need the knowledge about factoring. Number 3, apply the zero product property rule. This one. Number 4, solve each equation. And last one, check each root by substituting in the original equation. Let us have an example. Here, I am going to solve this quadratic equation through determining the greatest common factor, the GCF. So, step 1, we have to write the equation in standard form. This is already in standard form. Right side is equal to 0 and a is greater than 1. Step 2, factor the equation completely. Like what I've said, we're going to solve this by determining the greatest common factor. The greatest common factor of 20 and 15 is 5. The greatest common factor of x squared and x is x, the one with the lower exponent. So the greatest common factor of this is 5x. Now, how did we arrive with 4x? 20x squared divided by 5x. 20 divided by 5 is 4. X squared divided by x, you still have 1x. This one, negative 15x divided by 5x. 15 divided by 5 is 3. Then x will simply cancel out. Step 3, apply the zero product property rule. So the first factor, 5x, let us equate that to 0. Or the second factor, let us also equate this to 0. Step 4, solve each equation. Let's have the first one. We have to solve the value of x. We have to eliminate this 5 here. So what we are going to do is to divide both sides by 5. This 5 and 5 here will cancel out. So we'll only have x. And 0 divided by 5 is still 0. For this one, we're going to move negative 3 first on the other side. It will become positive. Then to solve for x, we have to divide both sides by 4. So 4 and 4 will cancel out. So x is equal to 3/4. And finally, check each root by substituting in the original equation. So let us substitute first 0 in the original equation. So all x's here will be replaced by 0. Are they equal? 0 squared is 0. And 20 times 0 is 0. 15 times 0 is also 0. Is that equal to 0? Yes, of course. 0 is equal to 0. Next one, let us substitute 3/4 in all of our x's here. 3 squared is equal to 9. 4 squared is equal to 16. So we have 20 times 9 over 16. And then 15 times 3 is 45. So we have minus 45 over 4. Is that equal to 0? 20 and 16 are both divisible by 4. 20 divided by 4 is equal to 5. 16 divided by 4 is equal to 4. So we have 5 times 9, which is 45, divided by 4. Copy minus 45 over 4. Is that equal to 0? 45 over 4 minus 45 over 4 is 0. Yes, it is equal to 0. Therefore, our answers x equals 0 and x equals 3/4 are correct. Let's have another one. This time, I'm going to solve quadratic equation that is of perfect square trinomial, PST. I have here 9x squared minus 24x equals negative 16. Step 1 again, write the equation in standard form. So I'm going to move negative 16 on this side. It will become positive and then equals 0. Next step, factor the equation completely. First, let us examine this. Is there a common factor that we can factor out? 9, 24, and 16. There is none. Next, is this a perfect square trinomial? How do we determine? First, let us get the square root of the first term. That would be 3x. Then the square root of 16, that would be 4. Copy the sign of the middle term and then quantity is squared. Again, the square root of 9x squared is 3x. The square root of 16 is 4. Copy the sign of the middle term and then square it. To see if this is a perfect square trinomial, you multiply these two. 3x times negative 4 is negative 12x. And then multiply it by 2. Negative 12x times 2 is negative 24x. And that is our middle term. So yes, this is a perfect square trinomial. And this is the factor. Step 3. Apply the zero product property rule. I have here quantity 3x minus 4 squared. That is the same as having 2 3x minus 4. So I could use just 1. 3x minus 4 is equal to 0. Next step, solve each equation. I only have 1 here. I'm going to move negative 4 on this side. It will become positive. To solve for x, let us divide both sides by 3. 3 and 3 will cancel out. So we have x is equal to 4/3. And finally, let us check our answer by substituting this in the original equation. So let us replace all x's here by 4/3. Are they equal? 4 squared is 16. 3 squared is 9. So we have 9 times 16 over 9. 24 is divisible by 3. 24 divided by 3 is equal to 8. So we have 8 times 4. Is that equal to negative 16? 9 and 9 here will cancel out. So we have 16. And then 8 times 4 is 32. Is it equal to negative 16? 16 minus 32 is negative 16. And yes, they are equal. Therefore, our answer 4/3 is correct. But remember, this is squared, so meaning twice of this. Let's have another one. This time, we will be having a trinomial with a is equal to 1. So again, step 1 is to write the equation in standard form. Let us simplify this. X times x is x squared. X times negative 4 is negative 4x. Then let us move this 5 on this side. It will become minus 5 equals 0. Next step is to factor the equation completely. Let us examine our quadratic equation. Is there a common factor that we can factor out? We have 1, negative 4, and negative 5. There is none. Next, this is a trinomial. Is it a perfect square trinomial? No, this is a quadratic trinomial wherein a, the numerical coefficient of x squared, is equal to 1. So how do we solve the factors of this? So first, what I do is to determine the factors of 5. The factors of 5 are just 1 and 5, no other factors. And then I'll create my magic x. What I am going to write on the topmost is the third term, which is negative 5. Then at the bottom, I am going to write the numerical coefficient of the linear term. So that is negative 4. Now, since I only have one pair of factors, then I'm going to write this on both sides, left and right, 1 and 5. Here is the tricky part. You're going to think of the signs of your factors. So it should give you a product of negative 5, meaning one of this should be negative. And also, when you add them, it should give you a sum of negative 4. So what do you think must be the signs of your factors? To give you negative 4, your 5 must be negative because 1 plus negative 5 will give you negative 4. And 1 times negative 5 will give you negative 5. Now, I already have my factors. That would be x plus 1 and x minus 5. Next step, apply the zero product property rule. So I have x plus 1 is equal to 0 or x minus 5 is equal to 0. Solve each equation. Moving 1 on the other side will become negative 1. Here, I'll move negative 5 on the right. This will become positive 5. Finally, let us check. Let us substitute these values in our original equation. Let's start with the first one, negative 1. Let us replace all x's here by negative 1. Are they equal? So we have negative 1 minus 4 will give you negative 5. Is it equal? Negative 1 times negative 5 is positive 5. And yes, they are equal. Now let us move to the second one. Let us replace all x's here by 5. Are they equal? 5 minus 4 is 1. Is 5 times 1 equals 5? 5 times 1 is 5 and so it is equal to 5. Therefore, our answers x equals -1 and x equals 5 are correct. Let's have another one. This time, the quadratic equation is a trinomial wherein a is greater than 1. So this is much difficult, just a little bit. Okay, so again, first step is we have to convert this into standard form. So I'm going to move 8 on this side. It will become -8 equals 0. And then to solve for the factors, I'm going to need a table for this. Two columns, one is labeled as multiply and the other one is labeled as add. So where am I going to get the values that I will put here? First, I am going to multiply the numerical coefficient of x squared, that is 3, with the constant term. So that is for letter M. 3 times -8 is -24. I'm going to place it here. Next, I am just going to copy the linear coefficient of the middle term. This is for the a. So I'll place it here, +2. I call this method as MA method. Now, what am I going to place here? I'm going to think of factors of -24. So it could be -1 and 24. -1 plus 24 will give me 23 as an answer. Another factor, I have -2 times +12. When I add these two, it will give me +10. Another factors, I have -3 and +8. When I add these two, this will give me +5. Another factors, I have -4 times 6. When I add this to -4 plus 6, it will give me +2 as an answer. Bingo! This is what I am looking for, +2. Next step is I am going to write +2x as the sum of -4x and 6x. So that would be 3x squared minus 4x plus 6x minus 8 is equal to 0. I just rewrite +2x as -4x plus 6x. Where did I get this? The factors of -24, -4x and +6x. When I add these two, it is the same as +2x. Next, I am going to group terms with common factors. So let me just group these two and these two as well. From here, I can factor out the greatest common factor. So for the first group, the greatest common factor is x. X squared and x, I can factor out x. So I have x times 3x minus 4. Let us do quick checking. X times 3x is 3x squared. X times -4 is -4x. Now, for the second group, the common factor is 2. So 6x divided by 2 is 3x. 8 divided by 2 is 4. Then copy the sign, minus. Quick checking, 2 times 3x is 6x. 2 times -4 is -8. Looking at our equation here, there is again a common factor that we can factor out, and that would be 3x minus 4. So when we factor out 3x minus 4, what was left here is simply x, and in here is plus 2. So we have x plus 2 equals 0. Now we can apply the zero product property. So we have 3x minus 4 is equal to 0, or x plus 2 is equal to 0. Let us solve this one. Let us move -4 on the other side. It will become positive. Dividing both sides by 3, we will be having x is equal to 4/3. On this one, let us move 2 to the other side. It will become -2. I would like you to check our answers by substituting these values in the original equation. Try this. We have 2x cubed minus 18x equals 0. So first, ask yourself, is there a common factor that you can factor out? 2 and 18, you can factor out 2. X cubed and x, you can factor out x. So we can factor out 2x. So what is left is x squared minus 9. How did we get this? 2x cubed divided by 2x, 2 will cancel out. X cubed divided by x is x squared. 18x divided by 2x, 18 divided by 2 is 9. Then x will cancel out. Quick checking. 2x times x squared is 2x cubed. 2x times negative 9 is negative 18x. We can still factor this difference of two squares. We solved this earlier. That is x minus 3 and x plus 3. So the first factor is 2x, and then the factors of x squared minus 9 are x minus 3 and x plus 3. Let us apply zero product property. 2x is equal to 0, or x minus 3 is equal to 0, or x plus 3 is equal to 0. To solve for x, let us divide both sides by 2. So 2 will cancel out here, and 0 divided by 2 is still 0. For this one, let us move negative 3 on the other side. X is equal to positive 3. Here, let us move positive 3 to the right. This will become x equals negative 3. Let us check. First, let us substitute 0 in our original equation. Are they equal? So we have 0 cubed is 0, and 18 times 0 is also 0. 0 minus 0 is definitely equal to 0. Next, let us substitute 3 in our x's here. 3 cubed is equal to 27. 18 times 3 is equal to 54. 2 times 27 is 54. Minus 54, is that equal to 0? Yes, it is. Last one, let us substitute negative 3 in our x's here. Negative 3 cubed is negative 27. And 18 times negative 3 is negative 54. 2 times negative 27 is negative 54. Minus negative 54 will become positive 54. Negative 54 plus 54 is equal to 0. Therefore, our answers are correct. Let's have some more. X squared plus 4x plus 8 is equal to 8x plus 29. Quite long, isn't it? But don't worry, we can solve this. So let us write this in a standard form. Let us move 8x to this side as well as 29. Let us simplify this. Positive 4x minus 8x will give us negative 4x. Positive 8 minus 29 will give us negative 21. Now we have a trinomial. Is there a common factor that we can factor out? We have here 1, and this one is 4, and then 21. There is none. Is this a perfect square trinomial? Square root of 21 times 2, will it give negative 4? I don't think so. So this is a trinomial wherein the numerical coefficient of x squared is 1. I'm going to use my magic X. First, let us determine the factors of 21. 1 times 21 and 3 times 7. Let us bring out our magic X. What do we write on top? The constant term. And at the bottom, the numerical coefficient of the linear term. Now think, which of these two factors will give you negative 4 when you add them? That is possible in 3 and 7. Think of the signs. It should give you negative 4 when you add these two. If you want negative 4, then 7 here must be negative. 3 plus negative 7 will give you negative 4. And 3 times negative 7 is negative 21. So here are the factors that we are looking for. We have x plus 3 and x minus 7 equals 0. Let us apply the zero product property. X plus 3 is equal to 0, or x minus 7 is equal to 0. To solve this one, moving 3 to the other side, it will become negative 3. Moving negative 7 on the other side will become positive 7. Now, let us check our answers. Let's start with negative 3. Let us substitute negative 3 in all of our x's here. So we have negative 3 squared is positive 9. 4 times negative 3 is negative 12. 8 times negative 3 is negative 24. 9 minus 12 is negative 3. Negative 3 plus 8 is 5. Negative 24 plus 29 is also 5. So 5 is equal to 5. Let's have the second x. This is 7. Let us replace all x's here with 7. So 7 is squared is 49. 4 times 7 is 28. 8 times 7 is 56. 49 plus 28 is 77. 77 plus 8 is 85. On the other side, 56 plus 29 is also 85. Our answers x equals negative 3 and x equals 7 are correct. Let us do extra challenge. The square of a number minus twice the number is 63. Find the number or numbers. First, let x be the number. It says here the square of a number, so that would be x squared if x is our number. Minus twice the number, so minus 2x. Is equal sign, then 63 equals 63. Let us write this in standard form. Let us move 63 on the other side. This is a trinomial where a is equal to 1. Let me determine the factors of 63. 1 and 63, 3 and 21, 7 and 9. Now let us bring out our magic x. What do I write on the top? The constant term, negative 63. How about at the bottom? The numerical coefficient of the linear term, and that is negative 2. Now, I'm going to choose which among these three factors will possibly give me negative 2 when I add them. I suppose your answer is 7 and 9, and that is correct. Now, for the signs, I should have a product of negative 63, meaning one of these two should be negative. And for the sum, I should get a sum of negative 2. So in that case, 9 here should be negative. Quick checking. 7 times negative 9 is negative 63. 7 plus negative 9 is negative 2. So these are the factors that we are looking for. So we have x plus 7, x minus 9 equals 0. Applying the zero product property, x plus 7 is equal to 0 or x minus 9 is equal to 0. So this will be x equals negative 7 and this one will become x is equal to 9. Let us check our answers. First, let us substitute negative 7 in our equation here. Negative 7 squared is positive 49. Negative 2 times negative 7 is positive 14. 49 plus 14 is equal to 63. They are equal. Next, the second one, x is equal to 9. Let us substitute 9 in our equation here. 9 squared is 81. And 2 times 9 is 18. 81 minus 18 will give you 63. They are equal to. Therefore, our answer, the numbers are negative 7 and positive 9. Let's have another one. The length of a rectangular garden is 5 feet more than its width. The area of the garden is 176 square feet. What are the length and the width of the garden? So first, let us let width be equal to W. And length is equal to W plus 5. Why? It says here, the length of the rectangular garden is 5 feet more than the width. So that is 5 feet more than the width. And we also know that the area of a rectangle is equal to length times width. Since we already have the value of L, which is W plus 5, I can substitute it here for L. So I have quantity W plus 5, the value of my L, times the W, I simply copy that, equals the area, which is 176. Let us expand this. W times W is W squared. W times 5 is 5W equals 176. Let us write this in standard form. Let us move 176 to this side. It will become minus 176 equals 0. This is a trinomial wherein A is equal to 1. So let me determine the factors of 176. 1 and 176. 2 and 88. 4 times 44. 8 times 22. 11 and 16. All of this, when multiplied, will give you 176. Let us bring out our magic X. The one that we put on top is the constant term, negative 176. And at the bottom is the numerical coefficient of the linear term. So we have positive 5. Now think, which of these 5 set of factors will give you 5 when you add them? The answer is 11 and 16. Since our product is negative, one of these two should be negative. Is it 11 or 16? Take a look at the sum. You should get a sum of positive 5. If you want a sum of positive, then the smaller number should be negative. Quick checking. Negative 11 times 16 is negative 176. Negative 11 plus 16 is positive 5. Therefore, here are the factors that we are looking for. So we have W minus 11 and W plus 16 equals 0. Let us apply zero product property. W minus 11 is equal to 0, or W plus 16 is equal to 0. Let us move this on the side. W is equal to 11. Moving this on the right, W is equal to negative 16. Since we are looking for the width, there is no negative width. So we're going to choose the positive one. We already have the width. This time we're going to determine the length. And the formula for the length is L is equal to W plus 5. Our W is 11. 11 plus 5 is 16. Therefore, our answer, the length is equal to 16 feet and the width is equal to 11 feet. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. In the figure below, the area of the shaded region is 144 centimeters squared. What is the length of the longer side of the figure? The longer side of the figure is obviously this one. So we are looking for this length. And this is equal to what? This is equal to S plus 6. Now this is the width and it is equal to S minus 4. We also know that the area of a rectangle is length times width. So we are going to use this and the given area, which is 144. I'm going to substitute S plus 6 for the length and S minus 4 for W. And that is equal to 144. Let us use FOIL method on this one. S times S is S squared. S times negative 4 is negative 4S. 6 times S is 6S. 6 times negative 4 is negative 24. Let us write this in standard form. Let us move 144 on this side. It will become minus 144. Let us simplify this. Negative 4S plus 6S is positive 2S. Negative 24 minus 144 is negative 168. This is a trinomial where the numerical coefficient of S squared is 1. Let me determine the factors of 168. 1 and 168, 2 and 84, 4 and 42, 8 and 21, and 12 and 14. Let us bring out our magic x. What we write on top is the constant term, negative 168. And at the bottom is the numerical coefficient of the linear term. This is positive 2. Now think, which among these 5 set of factors will possibly give you 2 as an answer when you add them? That would be 12 and 14. Now, this is negative. So, one of this is negative. And this is positive 2. If you want a positive answer, then the smaller number of these two should be negative. Quick checking. Negative 12 times 14 is negative 168. Negative 12 plus 14 is positive 2. So these are the factors that we are looking for. So we have s minus 12 times s plus 14 is equal to 0. Let us apply the zero product property. S minus 12 is equal to 0, or s plus 14 is equal to 0. To solve for s, let us move this on the other side. It will become s is equal to 12. To solve for s here, let us move 14 on the other side. It will become s is equal to negative 14. Since we are looking for the length, then of course, we're going to choose the positive value. This 12 is the s here, but we are asked to solve for the length of the longer side, and we represent that as s plus 6. So L is equal to s plus 6, and our s is 12, so 12 plus 6. So the length is 18. So our answer here is the length is equal to 18 centimeters. Gets? Our next lesson is solving quadratic equations by completing the square.